introducing Stratus 10 Cloud Computing Services. Stratus 10 is an Amazon Web Services advanced consulting partner that helps companies migrate to the cloud or implement best practices if they're already on AWS. Today, we will be presenting the latest in cloud and container security. Oscar is the co-founder and CEO of Stratus 10. His background is in artificial intelligence and software engineering and leading engineering teams at startups and Fortune 1000 companies. Kevin is the co-founder and CTO, and he has worked in the ITO and technical operations space for over 20 years. We are also proud to introduce our partner, AlertLogic. Founded in 2002, AlertLogic has helped more than 4,000 organizations rely on purpose-built technology and their team of security experts to protect their organizations and empower them to resolve what threats may come. Paul McBratney is a veteran of the IT industry with many years of hands-on experience in Windows and network administration and a background in hosting, cloud, co-location, and on-premise deployments. I do have a short poll to gather each participant's knowledge level before we jump into the event. I'll run over an agenda while I give you a few seconds to answer the polls. Before we get started, here's our agenda for today. Now that we've ran through introductions, Kevin will kick off our presentation on security. Following our presentation, AlertLogic will be presenting, and then you guys will have an option to ask live questions and get specific answers. I'm going to give you guys about 20 more seconds for the poll before I pass this off to questions. Also, if there's anything specific that you guys are hoping to learn today, just please feel free to drop it in the chat, and we can make sure that we discuss that throughout the presentation. All right, please submit your answers if you haven't. And another warm welcome as I'll turn it over to Kevin to kick us off.
Thank you, Lexi. Good afternoon, good morning, everybody, depending on where you are in the world. So I wanted to talk quickly about security in the cloud, and particularly the AWS shared responsibility model. Security and compliance is a shared responsibility between you as the end user and AWS. The shared model helps provide or relieve your organizational burden as AWS operates, manages, and controls the components from the host operating system and virtualization layer down to the physical security of the facilities in which the services operate. This is what AWS always refers to as the undifferentiated heavy lifting. So oftentimes during sales presentations, you assume the responsibility of managing the guest's operating system, including any updates and security patches, and then other associated applications that you put on top of the guest OS, as well as configuring the AWS security groups, which is their version of a firewall. So what are containers? And containers is actually not a very new concept. If you think of them as essentially a means of isolating what you're trying to run. Way back in, as far as 1979, Chroot was introduced via Unix. And that started the separation of isolating what you're running from the actual operating system. Fast forward a little bit to about 2008, and LXC was introduced, which was allowing you to run multiple isolated Linux instances. And then forward into 2013, where Docker was debuted at PyCon. And basically fast forward to present day, and containers have taken over the world with Docker and Kubernetes as the technology of choice. Docker being the containerization technology, and Kubernetes being the current open source darling for providing that orchestration of those containers and running those workloads. but there are other solutions out there for orchestration. Next slide, please. So container security, what does this entail? Basically, there are several components that you need to be aware of when you're trying to secure your container host. And basically, this is what those containers will run on. So it's important to secure that host by implementing standard security practices, such as hardening the operating system, minimizing the number of packages installed, and restricting access to it. Along the lines of network isolation, things like when using Kubernetes, for example, you may use network isolation to segregate your pods inside a cluster. We'll touch on that a little bit more from an AWS perspective. The build and deployment process. You can add security to your container build and deployment process by scanning your images, making it automated as part of every single build that you perform, and then having scans run after the fact for your images that are, say, a daily scan or a weekly scan if you're not updating your packages as often, just to make sure you're catching any sort of zero-day vulnerabilities that may have come out. And of course, container contents. What are you running in your containers? So much like the container host, you want to be aware of what you're actually running on the container. And Oscar will touch on this in a little bit more details for both the build and deployment as well as the container content. In addition, it's been mentioned that there are tools out there such as KubeAudit, which is a script by Shopify that will help you audit your container clusters against common security controls. You can also use a security partner such as AlertLogic to monitor in real time between containers and the local network. So let's talk about running containers within AWS. There's 4 ways that you can basically run a container on AWS: EC2, ECS, EKS, and Fargate. Each has advantages and disadvantages depending on the level of control that you want. They all share some common attributes, such as running on VPCs, the ability to route traffic through ENIs, the ability to use CNI, which are container network plugins. But let's look at EC2 first. So EC2 is when you want to take control of everything and you want to determine how you're configuring your container operations. Very customizable, but the downside is you're going to be doing everything yourself. There's not going to be much in terms of assistance for you. ECS is the next level. So ECS is an interesting solution because it is also the orchestration engine for Fargate. So when you launch containers within EC2 or ECS, you have a choice of either running it in ECS container instances, which are essentially EC2 instances, or Fargate, which has abstracted that EC2 layer and lets you run worry just about your tasks. EKS is Amazon's solution for, or Amazon's version of Kubernetes. And this allows you to run Kubernetes and manage reutilizing Kubernetes tools and technologies. When you're doing security within EKS, you would use the same tools available for regular Kubernetes, which is using network namespaces so that you can configure your pods to have their own IP addresses, their own ports. And as of this week, AWS no longer provisions public IP addresses for your EKS instances. So that's a relatively new security feature. And so if you do need access, you will need to start manually provisioning those out. And lastly, Fargate. Fargate is AWS's complete tooling, lets them do all the management orchestration. All you have to worry about are your containers and pods. Little tips and tricks for running containers within Fargate is that everything is considered a task. And you can apply AWS security frameworks around those tasks, such as security groups, IAM roles. You can even use private links, which are ways that a resource within your VPC can access other AWS resources without having to go out the internet. So things like pulling your images off of the ECR, which is the repository for from AWS. You can do all that now within your VPC, so none of your images or data is transmitted over the network. All right. And with that, we've touched on kind of a little bit of the services that AWS has to offer and how you can run containers on them. I'm going to go ahead and hand over to Oscar to talk a little bit more about the various different processes.
Thanks, Kevin. Good afternoon, everyone. I'm going to talk a little bit about DevSecOps and containers. DevSecOps is basically integrating security into your DevOps process or making it part of your CI/CD or deployment pipeline. So adding security to your DevOps process can help make sure your application meets security compliance requirements. It can help you minimize the number of vulnerabilities in your application as well. When running a large number of applications or containers, it becomes really hard to keep track of compliance and finding those vulnerabilities. Luckily, there is an app for everything, right? Or in this case, there's tools for these situations. There's open source tools such as CoreOS, Claire, and Anchor that can help you maintain security compliance and check for those known vulnerabilities. AWS has a relatively new tool to help you scan container images for known vulnerabilities. It's called AWS Native Container Image Scanning, kind of a long name, but it's part of ECR. And ECR uses the common vulnerabilities and exposures database from the open source CoreOS Claire project and provides you with a list of findings. Those checks are checks for vulnerabilities in packages that you're using in your operating system. You can manually scan images stored in ECR, or you can create automation to scan these images when they're uploaded to your ECR registry. However, the container image scanning is free, but you can only scan images once per day. So even if you build automation to scan these images, it won't allow you to scan them more than once every 24 hours. Kevin also mentioned how it's important to secure the contents of the container. So you want to make sure that the contents of the container are secure and free from any known vulnerabilities. One of the things we have to be very careful about is open source libraries. Open source libraries are used in most applications nowadays, from web servers such as Apache to application-specific libraries for specific things like machine learning and artificial intelligence tasks. Open source software, it's great, but just like anything that's free, comes with some gotchas, right? Software composition analysis is a relatively new industry term for a set of tools that provides users visibility into their open source inventory. SCA can be used to look at every library in your code or your software or your API and the version of those libraries to detect known vulnerabilities. It's a good way to get rid of low-hanging fruit when it comes to securing open source libraries. It also allows you to create a bill of materials of your application, which is basically a list of every library that you're using with their version, and that's how it determines if you have specific known vulnerabilities. And here's some tools that you can use to run software composition analysis on your application, such as Snipe.io, Black Duck, and IQ Server. See, another important part of security around containers is monitoring threats inside the environment, right? So not only do you want to look at how your container is built, but also the environment that is running on. So looking at things like container to container network traffic, container log data, and changes to the platform or the AWS services that containers are running on, it's all important in order to secure your environment. So these are the things that you can do with the help of solutions like Alert Logic. So with that, I'll pass that along, to Paul, who's going to talk to us a little bit more about using Alert Logic to secure your container environments.
Great, thank you. Actually, can you pass me the screen share? There we go. Thank you. Is everyone able to see my screen? Excellent. Again, I'm Paul McBratney. I'm one of the solutions engineers with Alert Logic. One of the things I really love that I'm hearing is if you go and read some articles on SANS.org, which is one of a great resource for security, what you're hearing is a defense in depth strategy, where you're doing multiple things operationally and also from a security perspective to secure your environment. We need to break this concept of there's a single tool that's going to make you successful, that there's a single thing that you can do that will help protect you from attacks. There are actually layers of tools and layers of operational things that you need to do. Just like you have firewalls, you have antivirus, there are also things in the operational realm, segmenting things out into different networks. In the old world, segmenting things out into firewalls, firewall zones. One of the things we were really struggling with, and a lot of companies in the security space were also struggling with this a year or two ago, was how to protect containers. And if you can't monitor the container network and pull back the logs and inspect those for indications of attack or compromise, then you have a real problem. If you've got a compliance requirement that says that you will monitor the network, that you will look at the log data, and you can't do that in a particular environment, that means you start having to do something called data classification, where you say, oh, well, I have a PCI requirement. This group of data has to be PCI compliant. If I can't monitor it, I can't put it in the container environment. And what happened with us is we had a couple of large customers that came up against this problem. And as often happens with a lot of companies, that kind of helped us move the ball down the field and get our product team engaged in how to solve this problem for our customers. So we've been talking about Docker and Kubernetes and Amazon. There are lots of different environments that these work in, not just Amazon, but it's vital that you secure this along with the rest of your virtual infrastructure. And we tried a couple of different methods. If you've ever worked with us, our primary way of solving these problems is on EC2 instances, you install an agent and it collects the network traffic and it collects the log data and it pulls that back for us to inspect, and away you go, and it's very, very simple. We had a little issue. As soon as we stepped into the world of containers, if you just put that agent on the individual host, on the servers that are hosting the cluster, you only got the traffic that was going between those host servers. You didn't get the agent-to-agent traffic. And we learned very quickly we had a problem to solve. And the way that we solved that was we built our own container. You import our container. This is actually where the GitHub repository where you download this from. And you put this into your cluster. And I want to step through how this works. But there's an interface called Docker 0. And that's the network interface where the container-to-container traffic travels. And one of the things that's always been very important to us, whether you were talking physical servers, VMware, AWS, is we want to inspect the internal traffic, not just what comes from the internet, not just what goes out to the internet, but our methodology has always been to inspect all the traffic that went to every server and all of the traffic that went from every server. So if someone manages to get past the firewall or past your network security policies and land on a server and then start to move across your environment, what we call in the security world, moving laterally, we wanted to be able to see all of that and be able to pinpoint this is what happened and they started here and then they installed this exploit and they moved here. So you could actually fight the attack. And this was challenging with containers. What we found was by creating our own container, spinning it up in the cluster, we now had insight and could pull back that network traffic on the container network. Now, this isn't for us, this isn't just about monitoring containers. This is one element that customers desperately need. But in an AWS environment, it has to be holistic as well. So we're covering the actual EC2 instances, But earlier we were talking in the previous presentation too about segregating traffic between groups of containers. Well, imagine some of your EC2 instances might actually be connected and talking across the network to those containers. So we have to actually be able to monitor the traffic from the EC2 instances to the containers. The attack could go either way. Likewise, we're also able to scan all of your instances for vulnerabilities. Now, currently, we're not scanning for vulnerabilities within the container environment. That may come at some point, but as was mentioned earlier, there are some good tools within that. We're also pulling back the log data for the EC2 instances and the log data itself through CloudTrail off of the platform. We can also monitor S3 buckets, and a lot of times for the container log data, you store it in an S3 bucket in order for it to pull that back. So what we were trying to really accomplish by adding containers into what we're managing, what we can monitor, is a way to spot active attacks, both from the servers, via IDS, via network traffic, through the logs for both servers and containers, and also the logs off of the platform itself. And the way that we accomplish this on the network data, we have an IDS appliance in the environment that basically looks for suspect traffic and ships that back across our big data platform where it gets inspected more deeply, and we determine if there's actually an incident there or not. Likewise, we pull back all of the log data. We inspect that more deeply with our security content to determine if there's an incident there. When there is an incident, the incidents get scored as low, medium, high, or critical, and the highs and the criticals go to our folks in the SOC. Their job is to dig deeper into that incident, whether it's looking at a handful of network packets or a handful of logs, to determine what else does our customer need to know about that, what do they need to do to remediate, and then on the highs and criticals, they actually pick up the phone and call the end customer and help them understand what to do. So it's that phone call from the person that actually is the expert, the person that actually identified additional details within the incident, that picks up the phone and calls the customer. So that's the end of my presentation. Do we have some questions for the presenters?
We actually do have a few questions. I'm just going to start this off. If you guys want to drop any in the Q&A or the chat, feel free now. The first question we have from our audience: what is the difference between software composition analysis and the AWS image scanning service?
I can answer that. So software composition analysis looks at every library in the code or the API that you're running, right? And looks at the version of that library to determine if there's any known vulnerabilities. Whereas the image scanning service that AWS provide looks at versions of packages in the operating system and just gives you a list of known vulnerabilities in those packages.
Awesome. And it sounds like running containers can be pretty risky. What are the advantages of moving to containers? Anyone?
Yep. I can take that as well. So if you move from a VM to containers and just do a lift and shift, you're still going to have to mitigate some of that risk. You can add things like compensating controls to mitigate the risk, such as blocking admin pages from the general public, but it doesn't really fix the issues. So some of those issues still need to be addressed when you move to containers. So it's not riskier, it's just a different way to mitigate the risk.
This is Paul from Alert Logic. Just one point to add. I don't see containers as more risky. I see a greater opportunity to isolate resources. So on the security side, it has its plus side too, if you use the tools that are available to you.
Excellent point. And then back to the scanning service. Does the AWS scanning service automatically scan container images?
It does not. You have to scan them from the console. However, you have to scan them from console manually, but you can create automation to scan those automatically. But remember that you can only scan your images once a day, once every 24 hours. So even with automation, you won't be able to scan them all the time.
Awesome. Let's see. Does anyone have anything else they'd like to add? If you guys want to direct any questions or feedback on the presentation, we'd love to hear from you. Before I close out, I do an exit poll. I'd love to get your guys' feedback, just kind of what you thought of today's event. Oh, it looks like we have one more question coming in, so I'll let you guys vote. So, how do we support zero trust networking? Paul, would you like to tackle that?
Yeah, I don't have specific experience in that, so I don't have a great answer.
Okay. And then are you guys still able to see the poll? We can get back to you guys with any other questions just for the sake of time. If you guys can just finish out with the poll questions. I will also be sharing a recording of today's screen and this webinar for you guys to share with your colleagues, as well as the slides. And thank you for